This is just a very quick demonstration of the space heat requirements. We did go through this in class, but here we go. This is our calculation tool. It's an early stage design tool developed by a project, Edinburgh Homes project. Let's not worry about the LCA data here. What we're more interested in is just the output, which we call the space heat requirement. And it has been corrected for the Edinburgh-based area. The calculation approach has been taken from a SAP calculation method. So in the yellow is the areas where we put our data. Now I've calculated this for you for how the building is just now. It's ground floor area and roof's the same, and the height of the auditorium. Let's have a look at the building. So in this example, I'm going to ignore the kitchen for just now, but I'm only looking at the entire envelope of the existing building. I'm going to take it as one large area. So back to this. I've got user-defined parameters of this is the U values that we have here. We've got doors, windows, ground floor, walls, and roof. And then we also have the air permeability or air tightness as 15. To be fair, that's fairly optimistic. It's probably a little bit worse than that, but we'll assume that for just now. And this is our areas. This is inputted for you. I took this data from the SketchUp model. My psi value or my thermal bridging value 4.4, we'll leave that as is for just now. And then from this here, the calculation tool predicts what the space heat requirement would be for 1 calendar year or for 12 months. So this would be 75,476 kilowatt hours just to heat that building. So if I move this to one side and then use this other tool, oops, do that just now. And for this tool here, for just now, I'll show you what this is. The cost of fuel at the moment, we find the electric from the grid can be as high as 29 pence per kilowatt hour. And we've also found it as low as 14.7 pence per kilowatt hour. For this calculation, we'll be taking the lowest price, assuming that you would choose to the lower provider. And for natural gas, we're finding prices as high as 7 pence per kilowatt hour, but also as low as 3 pence per kilowatt hour. Then of course there's different types of heating systems. The first being an electric bar heater. This is the sort of thing that we're referring to. That has an efficiency rating of 1. So 1 kilowatt of power in, you get 1 kilowatt of power out. An air source heat pump would have 1 kilowatt of power going in, i.e. electric, and from that, on average within Scotland, it all depends upon a whole number of factors, but we've came to a number of 2.4 kilowatts of heat would come out from that system. Of course, that will change seasonally and geographically on a whole number of factors, but for our area in Scotland, that's what we're getting on average at the moment. And then natural gas, a Worcester Bosch Green Star, which is probably the most common boiler that we fit at the moment as new. The efficiency is 1 kilowatt per 1 kilowatt hour in of natural gas. The efficiency would be 0.94 kilowatt hours out of heat. Now, so let's remove those numbers there. The current building without any improvements from that calculation that you just saw was 75,478 kilowatt hours. I'm going to propose a three-stage improvement to that building. My first improvement will be my walls. For my scenario, if I go to my BIM model, and if I pull up my wall panel, my wall panel from my demo, we have a U value of 0.182. But that's for my particular wall build-up. Your wall build-up will be different from mine, and you'll have to calculate your own U value. But my first proposal would be just to increase the efficiency of the walls only, and we'll get a number for that. My second stage would be the walls and to increase the roof insulation to 0.25. Then my third scenario would be to do the walls, the roof, and also think about the air permeability that's currently at 15. If I reduce that down to say 7, what would that do? Now, of course, you could do other scenarios. You could perhaps look at changing your floor, the ground floor U value. Or you could perhaps change the U value of the windows. That would be adding things like secondary glazing. Or even taking the existing windows out and putting new windows in, double glazed or triple glazed versions of the same. And that's a choice that you can make. But let's see how we would go about that. I'll just put this here just now. And if I just simply change my wall U value, doors, windows, wall. Wall type there. I go 0.182. Then I can see that my space heat requirement has changed to 4,609.47. And then in addition to that, if I go to my roof, doors, windows, roof is down here, sorry, here, and I change my roof to 0.25, which is fairly doable for that building to achieve. Then my space heat requirement become 38,256 kilowatt hours. And then my last one, my air permeability, it's currently at 15. If I change that down to say 7, and then that would then again 31,832 kilowatt hours. We could go on and change more things. We could obviously change the doors and the windows. The windows would be quite a big difference. And as we change the windows, that air permeability would come down even more as well. But for just now, these three-stepped approach is what I'm going to go with. Now I want to calculate how much this building would cost to heat using these three types of heating systems on these four different scenarios, the existing building as it is, and then my three-staged approach. So if I go equals, open brackets, my kilowatt hours multiplied by my cost of the fuel, which is 14.7 pence, close brackets, and I'll divide by the efficiency of the system. For the electric bar, it's 1. Now, anyone who's used Excel before knows that I'll need to hold some of the cells. So I'll put my cursor at E9, which is for the cost of my fuel, and I'll put a dollar sign in between the E and the 9 to hold it on the vertical, and then the efficiency of the system, I'll put my cursor at L6, so in between the L and the 6, and put a dollar there as well. And we'll just copy that and we'll paste it down here. So we can see to run that building as it is using an old-fashioned electric bar heating, which I hope nobody would ever think about doing these days, it would cost, this is to bring it up to a normal household temperature, it would cost in the region of £11,000 per calendar year just to run that building as it currently is. With my, just by changing the walls, bring it down to say 7,000, changing the walls and the roof, bring it down to 5,600, and then also changing the air permeability a little bit, bring it down to just over 4,500. That's just using the electric bar heating. If I were to go and install air source heat pumps, as we're being recommended to do by the government, it would be slightly different. So we'll open brackets, similar thing again, the kilowatt hour requirements multiplied by the cost of the fuel. It's still electric, we'll pick the lower one, and it's divided by the efficiency, 2.4. So let's hold again the E9 and the L8. So automatically, just by changing from the electric bar heating to air source heat pump, goes from £11,000 to just over £4,500 for the existing building as it is just now. And for my retrofits that I've chosen, it can go all the way down to just say £2,000 just for those simple retrofits. Now let's have a look at the existing system that's currently in the building, which is the natural gas boiler. It's a Green Star Worcester Bosch combi boiler. Open brackets, and we'll take the fuel required, multiplied by the cost, which is 3 pence per kilowatt hour, divided by the efficiency. And we'll have to hold the E13, that's the 13 we hold, and the L12, we hold the 12. So again, running that building as it is just now for a year is about just under £2,500 a year. And that, in actual fact, talking to the trustees, that is about what we're paying just now, or had been paying up until now. But with these retrofits proposed, if I copy that cell and bring these down, we can see over a financial year, we can go from £2,500 a year down to just over £1,000 a year. And that's not increasing the U value for the floor or the windows. That's only changing the walls, the roof, and the air permeability. So you can see with this approach, what we could do, we could have another 4 or 5 scenarios of what would be the best return for value for retrofitting. If I could only afford to do one retrofit at a time, what would be the best retrofit for return on investment, or my ROI? Well, I hope that this is a good example of how you could use a simple spreadsheet like this to show to your client retrofit options and give them a staged approach to retrofit. Thank you very much, and good luck.